So, again, the idea moving forward is you really have quadrant 1 memorized well. And what you'll do when you see a question like 7 pi over 6, okay, eventually you're just going to be able to say, I know this is negative 1/2. Why do I know that's negative 1/2? Well, because I know my reference angle is pi over 6, because it's part of my pi over 6 family. So if I have quadrant 1 memorized, I would know that sine of pi over 6 is 1/2. And 7 pi over 6 is in quadrant 3. So I would know that according to my cast rule, sine has to be negative in quadrant 3. Eventually, for today we're going to write this all down. Eventually what's in the green box is just mental math, stuff that you think about. I know it's my pi over 6 family, so I know it's 1/2. I know it's in quadrant 3, I know my cast rule, so I know it's negative. So therefore, sine of 7 pi over 6 is negative 1/2. So tan of 2 pi over 3. Because I have quadrant 1 memorized, I would know it's root 3. And here in the green box, here's our thinking box. The first thing I would think about is I would know that this is part of the pi over 3 family. So I go to quadrant 1, and I know that tan of pi over 3 is root 3. Okay. Remember my memorization strategy I showed you the other day? I remember that 3 is 3. Pi over 3 family goes with root 3. Pi over 6 family went with root 3 over 3 because 3 plus 3 is 6. That's just a memorization strategy to help me remember. So now I know that. This is going to be in quadrant 2, 2 pi over 3. So if I think about my cast rule, in quadrant 2, I know that I have to add a negative out in front here. So this is the logic that we're using to solve for this. Thinking about what quadrant it's in, we're thinking about a reference angle, to find the value, and to find out whether it's positive or negative. Okay. Close to 7 pi over 4. I will do the thinking part, but if you can write down the answer before I do, that's awesome. Okay, so I'm thinking about my pi over 4 family. 7 pi over 4, I know is in quadrant 4. And were you able to write down the answer before I was? Root 2 over 2. So for your pi over 4 family, cos is always root 2 over 2. It's in quadrant 4, where cos is positive. Now, we get into the secondary functions, secant, cosecant, cotangent. First of all, if you're trying to figure out secant of negative pi over 4, you can, in your thinking box, think about cos of negative pi over 4. Notice I never change the angle. Okay? We never flip an angle. So if you wrote 4 over pi, that is a mistake because angles don't change from reciprocals to their primary function. So I know this is part of my pi over 4 family, which is root 2 over 2. I know that root 2 over 2, this is in quadrant 4. So it's going to be positive. So I know that cos of negative pi over 4 is root 2 over 2. Okay? I'm going to remind you that when we did our special triangles, that root 2 over 2 can also be written as 1 over root 2. Because this sometimes comes up in multiple choice questions. Okay? If this was a long answer question, once you get what cos is, that cos is root 2 over 2, you can write that secant is the reciprocal. Secant would be 2 over root 2. Most likely, if this was a multiple choice question, would show up as root 2, because that's flipping 1 over root 2. If I flip 1 over root 2, do the reciprocal, I'll get root 2 over 1. Okay? Let's say you get 2 over root 2 and you're stuck. How do I get to root 2? Well, remember in grade 11 when you rationalize denominators? So you could rationalize the denominator and get root 2 that way as well. In grade 12, you can leave a square root on the bottom of the fraction. In grade 12, they assume you know how to rationalize denominators and don't ask you to do it. Say, we know you know how to do that. So if you leave it, that's fine. Okay? Where do they check to make sure you know how to do that? Is in multiple choice questions. Because they'll usually have a simplified form, and if you don't know how to do it, then your answer won't match with anything that shows up. So again, here in my thinking box, I see cotangent, so I think tangent. Angle doesn't change. Pretty obvious that this is part of the pi over 6 family. So I already know it's going to be root 3 over 3 because I know my pi over 6 family for tan in quadrant 1 is root 3 over 3. I still have to figure out what quadrant 11 pi over 6 is. Now if I think in the positive direction, 11 pi over 6 is on my pi plane. It's right here in the positive direction. That goes all the way to the 4th quadrant in the positive direction. So if I went that same distance in the negative direction, 1, 2, 3, 4 quadrants in the negative direction, do you see that it would be in quadrant 1? So then I know, and I'm adding the plus sign there just to show that I thought about it, right? Obviously you don't have to have a plus sign in front if it's positive, but I put it there to tell myself, oh, you did think about what it should be, and you made a note of that. But then when I go to write, and I'll remind you from our thing over there that that's also 1 over root 3. So you could write this as 3 over root 3 or just root 3. Cosecant, negative pi over 2. So in my thinking box here, if I see cosecant, I think about sine. Sine of negative pi over 2. Right? This is part of my axes family. Negative pi over 2, it's not really in a quadrant, the axes family. They're always like in between. Negative pi over 2 is down here at the bottom, right? It's in between quadrant 3 and quadrant 4. But we can't really say it's in a quadrant. As soon as you get an axes family, just think about the coordinate. The coordinate down here at the bottom, right? This coordinate right here has an x coordinate of 0 and a y coordinate at negative 1. And using the big idea that all of our coordinates on our unit circle, the x coordinate is cos theta, the y coordinate is sine theta, we would know that sine of negative pi over 2, since sine is the y coordinate, would be negative 1. And so that means, I'll write it out like this, that cosecant would be 1 over negative 1, which of course is still just negative 1. But I just showed the reciprocal idea to show that I was thinking about that. That every time I have cosecant, I do the reciprocal of sine. On the final exam, they take these little questions that we just did and like to make them 3-mark questions that look like this. I'm going to take half my page here is my thinking side, to show all my thinking, and then what I'm going to do is I am going to put answers underneath each one of these. So secant of 11 pi over 3, I need to put that answer. I'm going to need to put an answer for cos of negative 5 pi over 4, and an answer for tan of 23 pi over 6. And this question is going to take everything that we've done so far and combine it into one question. So it's going to take, right, locating an angle, that whole page that you did last night, all of those practicing things comes into here. It's going to involve knowing that secant is related to cos. It's going to take your pie plate, make sure you know reference angles, make sure you know values from your pie plate. So let's start with secant 11 pi over 3. In my thinking, I would think about cos of 11 pi over 3. First thing I would notice that it's my pi over 3 family. So I already know that cos of 11 pi over 3 will be a half. I just need to find out what quadrant 11 pi over 3 is in. Now in the assignment yesterday, we took 11 pi over 3 and changed it to a mixed fraction. And I'm writing that that 3 represents 3 pi. And 3 pi, right, here's 0. Halfway around is pi. Every time you have 1 pi, you go halfway around. Can you see that if you went 3 half revolutions, you would be right there. And we're going in 3 2/3 of the positive direction, so really I've got 1 pi, 2 pi, 3 pi has got me to that axis. And I need to go another 2/3. 2/3 is more than half. So in the next revolution of pi, and pi is a half revolution, I need to go more than a half of that half revolution. That's going to get me into quadrant 4. And I did all of that work to put a plus sign there. I now know it has to be positive 1/2 because cos is positive in quadrant 4 according to my CAS rule. All of this thinking lets me change in this first bracket. If cos of 11 pi over 3 is 1/2, then secant of 11 pi over 3 is 2 over 1. I'm going to draw a line there and do my next thinking. Cos, at least it's just cos. I know this is going to be root 2 over 2 from my pi over 4 family in quadrant 1. Where is negative 5 pi over 4? Again, 5 pi over 4 is on your pi plate in quadrant 3. So if you were going in the negative direction, you see that that same distance, 3 quadrants in the positive direction, 3 quadrants in the negative direction, is going to get you into quadrant 2. And cos is negative in quadrant 2. So then I can go here and write negative root 2 over 2 in that second set of brackets. Tan of 23 pi over 6. I mean, if you want to make your life easy, right, and you don't mind losing half marks, it's part of my pi over 6 family, so I already know it's root 3 over 3. You lose a half a mark if your sign is wrong. So if you want to lose a half mark, you just write root 3 over 3. In fact, you might actually get it right. So 50-50 could be positive, could be negative. Okay? If you don't like to lose half marks, which I hope you start to not like losing half marks, that you want to get as many marks as possible, well then we have to figure out where is 23 pi over 6. And as a mixed fraction, this is 3 and 5/6 pi. 3 half revolutions, well we already saw that 3 pi, 3 half revolutions ends on the negative x-axis there. Another 5/6 is still over half, so this will be in quadrant 4. Is tan positive or negative in quadrant 4? Negative, so we need to make that negative there, and then all of this thinking to get this. Okay? These are 3-mark questions on the exam. They give you 1 mark for secant, having the right numbers and the right sign. 1 mark for cos, having the right numbers and the right sign. 1 mark for tangent, having the right numbers and the right sign. They give you no marks for simplifying, but if you make a mistake, you will lose marks. So the next part of this question, they say, now we're just multiplying fractions. That's not something I have to teach you in grade 12, because you should know this already. So on the final exam, they award no marks for doing math that you're supposed to know already. They usually like to award marks only for stuff you're doing that's new. So right now I have 3 out of 3. If I make a mistake in my arithmetic, they'll take off a half a mark for making a mistake in my arithmetic. But now how do you multiply fractions? You multiply the tops, you multiply the bottoms. Maybe you'd like to do some simplifying, like, oh, 2 divided by 2 is 1. That makes life easier. A negative times a negative is positive. Root 2 times root 3, that's root 6. And what am I left with on the bottom? 1 times 1 times 3. Root 6 over 3 is my final answer.